Good morning children, hope you have a clear idea about carbon and its compounds as we have seen in the earlier class. Now let me continue with the tetravalency nature of carbon. Carbon has a unique property that it has 4 valence in its outermost shell. Okay, the electrons, number of electrons in its outermost orbital are called as its valency, and carbon's atomic number is 6. See, atomic number of carbon is 6, so we will put like 1s2, 2s2, 2p4. Okay, so obviously the four electrons are seen in its outermost shell. So according to Octet rule, carbon requires 4 electrons at the nearest noble gas neon electronic configuration. So carbon has the tendency to share its 4 electrons with other elements to prepare its octet. This is called as tetravalency. So the tetravalency, it's the tetravalent nature of carbon. See here, there are 4 electrons in its outermost shell and hydrogen is having 4 electrons, and obviously carbon will be sharing its electrons with hydrogen. So hydrogen, one hydrogen here, one hydrogen here, one hydrogen here, and another hydrogen here. This hydrogen will be having 4 electrons, and these 4 electrons are being shared within this hydrogen. So covalent bond is formed between the carbon and hydrogen. Okay, so multiple bonds. As seen above, the tetravalent carbon can form 4 covalent bonds. With this tetravalency, carbon is able to combine with other elements or with itself through single bond, double bond and triple bond. Okay, carbon has the tendency to form single bond, double bond and triple bond. Okay, see here. So the nature of bonding in a compound is the primary factor which determines the physical and chemical characteristic of a compound. So the ability of a compound to form multiple bonds is the main reason for the existence of various classes of carbon compounds. This table shows one of the classes of compounds such as hydrocarbons and the type of bonding in them. See here. Here the carbon has formed single bond with methane. Single bond with methane, and it is called as alkane. It has formed double bond with ethene. Okay, see the 4 bonds. See 1, 2, 3, 4. 4 bonds are there for this carbon, and 1, 2, 3, 4. This 4 carbons, 4 bonds are for this carbon. So it is called alkene. So see here, this carbon has shared 1, 2, 3, 4. 4 bonds are there. So totally 4 electrons are there. So carbon has the tendency to form a single bond, double bond, and a triple bond. So tetravalent. Another versatile nature, already we have seen this tetravalency, and now we are going to see about this isomerism. What is isomerism? What is isomerism? Isomerism is another special feature of carbon compounds, especially found in catenated organic compounds. Let us consider the molecular formula of organic compounds C2H6O. Can you name the compound? Because you can't, because the molecular formula of an organic compound represents only the number of different atoms present in that compound. It does not tell about in which way the atoms are arranged. So it is just in molecular formula, and there is no any idea of having an idea of how the molecules are being arranged. It does not tell about the way in which the atoms are arranged, and hence its structure. Without knowing the structure, we can't name it. So a given molecular formula may lead to more than one arrangement of the atoms. Such compounds are having different physical and chemical properties. So what is an isomerism is the phenomena in which the same molecular formula may exhibit different structural arrangements called as isomerism. Same molecular formula, different structural arrangement. They are having same molecular formula but different structures. They are called as isomers. Compounds that have same molecular formula but different structural formula are called as isomers. So they have given an example, the given formula C2H6. So we can arrange the C2H6 formula in 2 ways. First way is, see here, 1, 2, 1, 2. There are 1, 2 carbons. How many hydrogens are there? 3, 2, 1. 6 hydrogens are there. 1, 2, 3, 4, 5, 6 hydrogens are there. How many oxygen is there? Only one oxygen is there. So, this structural arrangement is correct for this C2H6O. And here also, how many carbons are there? 1, 2. How many hydrogens are there? 1, 2, 3, 4, 5, 6. Okay, there are 6 hydrogens. Only one O is there. So, this molecular formula. So, the same molecular formula, different structural formula. So, this is called as isomerism. Both the compounds have same molecular formula but different kinds of structural arrangement. In compound A, the oxygen atom is attached to a hydrogen and a carbon. It is an alcohol. See here. So, OH means, OH group means it is an alcohol. So, where is O? This is O. This is an ether. So, same molecular formula, different structural formula. So, this is an isomers. Okay. So, we have seen a tetravalent character for this, and we have seen the single bond, double bond and triple bond nature for the carbon. And next one, the isomeric property of a carbon. And next one we are going to see is the allotropic nature of carbon. So, what is an allotrope? Allotrope is the property by which an element can exist in more than one form that are physically different and chemically similar. What is an allotrope means? Allotropy means the one form that are physically different and chemically similar is called as an allotrope. The different forms of an element are called as allotropes. The main reason for the existence of allotrope of an element is its method of formation of preparation. Carbon exists in different allotropic forms, and what are the different allotropic forms or of carbon is? One is diamond and another one is graphite. One is diamond and another one is graphite. Carbon occurs in two different types of allotropic form. One is diamond and another one is graphite. Okay, let us see the properties of diamond. Each carbon has 4 covalent bonds in diamond. Each carbon has 3 covalent bonds in graphite. They are hard, heavy and transparent. Graphite are soft, slippery and touch and opaque. It has a tetrahedral units like 3 dimension. It has a planar layers of hexagon unit. It is a non-conductor of heat and electricity. It is a good conductor of heat and electricity. These are the 2 allotropic forms of diamond and graphite. Okay, is it clear? So, they have given, see here, the carbon has 2 types of allotropic forms. One is crystalline and another one is amorphous. Diamond, graphite, fullerene, charcoal, coke, lamp black and gas carbons, or these are examples for amorphous type. Okay, they have given diamond and graphite. Already we have seen the properties of this graphite and diamond. They have a tetrahedral fashion, dimensional structures, and they are linked by van der Waals forces. They are held by weak forces, but diamonds are held by strong forces. One more thing is fullerene. Another one more allotrope of carbon has been discovered. The third crystalline allotrope of carbon is fullerene. The best known fullerene is Buckminster fullerene. It consists of 60 carbon atoms joined together as a series of 5 to 6 members to form a spherical molecule. And if you see the structure of fullerene, you can have an idea. This is the structure of diamond, graphite and fullerene. Okay, so far we have seen about the carbon and its compounds, and now next class we will see the physical properties of carbon and its compounds. Okay, if you have any doubt, feel free to ask me in the WhatsApp group. Thank you.